All right, we're going to do one more section here. We're going to do part 3, come back to this problem here. This is a really good problem, but there's a lot of stuff going on. So we're going to finish up with this. Here's the picture. All right, you can already tell you've got a lot of segments here, a lot of intersection going on. The length of AB is 4x plus 7. Okay, so this right here is 4x plus 7. The length of CD is 25 plus 5x. Now CD is all of this right here. Now that certainly looks longer than AB. I don't know that yet. Now they say segment EC bisects segment AD. Now EC and AD, here's EC, here's AD. EC bisects this segment at C, right there. Now this is important to understand. This segment EF, this point B, has nothing to do with this statement right here. EC bisects AD and it hits AD at this point. So C is the midpoint of this. That means that from C to D is the same as from A to C. So it's not that 4x plus 7 equals 25 plus 5x. It's that this whole thing equals this. Now they also tell us that the length of segment EF bisects segment AC. So where's segment EF? That's here. That bisects AC. That would have to be at this point B, here. Okay, because where does EF hit AC? It intersects here. So that means this smaller piece AB has to be congruent to BC. Bisect gives you a midpoint. Midpoint means congruence. Find X and the length of BC. There are really two ways that these kind of problems will go. We're either going to make an equation where the two segments, the equivalent parts, are equal to each other. Okay, the two congruent segments would have to be equal, or we're going to have to add up to get something. Okay, and it's easier if I can just say segment AB is congruent to BC. The problem is they don't give us an expression for this. However, look at how we labeled segment AB is congruent to segment BC because B is the midpoint of AC. So if this is 4x plus 7, so is this. Now you may be tempted to say, okay, let's take AB plus BC plus CD to equal the whole thing. Now that would be great if they told us something about the length of AD, but they don't. They don't give us any kind of expression or number for that, so we're not going to do that. However, we do know that AC, this whole thing, is congruent to CD. Notice, by the way, that I marked those with one tally mark here and here, but the smaller ones I marked with 2. And the reason for that, why I use different numbers, is so that I don't confuse the different segments. So I can say that AC is congruent to segment CD. That means this whole thing is congruent or equal to this whole thing. So how do I find the whole thing here? For AC, I add. I take 4x plus 7 plus 4x plus 7 equals, in this case, this segment CD, which is 25 plus 5x. So this whole segment AC is congruent to CD, so that is equal to that. Okay, that's a really important relationship. You have to understand that to be able to come up with the equation. And this is why it's so important to label. Now, before we start moving variables, let's combine like terms. We can combine the 4x's, that adds up to 8x. Plus 7 is positive 14. I'm going to move the smaller variable, which is 5x. So to undo the addition, I'm going to subtract. So 3x plus 14 is 25. Then I'm going to move the constant. I'm adding that, so I will subtract 14. We get 3x equals 11. And we divide by 3, and we get a fraction here, 11 over 3. Now, as a decimal, you could say that's 3.6 repeating. In this case, I would prefer to keep it as 11 over 3. Now, honestly, I don't like the fact that I have a fraction, but it doesn't mean that I'm wrong, okay? You will get fractions and you will get decimals in geometry, in any math class, okay? So don't assume that you're wrong. Let's plug it back in and see if this actually works. So we wanted to find x, and we wanted to find the length of BC. Well, the length of BC is here. That was 4x plus 7. So if I take 11 over 3, if I do 4 times x plus 7, right there. And let's see, that's 44 over 3 plus, I can make this a common denominator, whoops, not 21, sorry, over 3. That would be 21 over 3. That's still 7. Now I can add my numerators and get 65 over 3. So this is 65 over 3. This is the same, 65 over 3. Now that doesn't tell me that I'm right though. So let me also plug it in to 25 plus 5x. Now 5 times x is 11 over 3. This is 55 over 3, 5 times 11. Again, let's get a common denominator. 25 over 1, that would be times 3. That would be 75 over 3. We can add the numerators now. 75 plus 55 is 130 over 3. Now that's this piece. And let's see if I want to check here. What should happen is that AB and BC together should add up to the length of CD because C is the midpoint. So if I take 65 over 3 and I add that to 65 over 3, I get 130 over 3, which is exactly what I get there. So the answer, I need to write it, we've got x equals 11 thirds, and we've got BC equals 65 over 3. As a decimal, that would be 21.6 repeating. And that is the end of the notes.